Okay, question 22, starred question, so I'm going to need to make sure my written communication is clear. The circle theorem questions are always very similar. They will give you some information that gives you a clue as to what rules you're probably going to have to use. So let's just start off. It says A, B, C, D are points on the circumference of a circle, centre O. So there are 4 points on the circumference of the circle, and that makes me think immediately I'm probably going to have to use the cyclic quadrilateral rule. It also tells me angle AOC at the centre is Y. I've got that on the diagram, so I'm going to get rid of that information because I've got it on the picture here. I've got to find the size of angle ABC in terms of Y. That just means I've got to find a formula that's got Y in it, or use a formula that's got the letter Y in it, and numbers if necessary. So this angle ABC, so what I want to find is this angle here. I've got to give reasons for each stage of your working out. This is really important, and it's the major part of the marks for this starred question. When I look at these problems, I just work backwards and say, if I want to find out this angle, which angle would I like to know? And I know, if I think of my cyclic quadrilateral, which it tells me here, I know that if I look at this shape here, this cyclic quadrilateral, that if I could work out what this one was, that these two add up to 180. Opposite angles in a cyclic quadrilateral add up to 180. So is there any way I could work out this one? Well, there's another rule I know. I know the angle at the centre is double the angle at the circumference when it shares a chord, which it does share. This chord here is hidden. So I know this angle here must be a half of Y, because the angle at the centre is double the angle at the circumference. And I know that this one plus this one add up to 180. So all I've got to do now is write that in a way where I can get some written communication marks for this exam question. So I'm going to say angle ADC equals a half Y. I'm going to put my reason in brackets here. The angle at the centre is double the angle at the circumference. I'm also going to know now that this angle plus this angle add up to 180. So I'm going to say angle ADC plus angle ABC equal 180. The reason for that, opposite angles in a cyclic quadrilateral add up to 180 degrees. Okay, then I'm going to use a little math symbol that says therefore. You don't necessarily have to use that one. I know that angle ADC is a half Y, so I can say a half of Y plus angle ABC equals 180. And now it's just like solving an equation. So angle ABC equals 180 minus a half of Y.